So Granny Smith to the green one. Green ones, right?
Yeah.
All right, those
So
are-
here we are. We're going to do this. I'm recording. So we're going to do this page. But we need the big three, right? We need the big three. Remember the big three. VF equals VI plus AT. VF squared equals VI squared plus 2 times AX. And then last but not least, X final equals X initial plus VIT plus 1/2 AT squared.
Sir, I have the big three branded onto my tip. Right there.
Thank you. So now that you're listening, that's what Mr. Barry had to offer.
Thank you, Ignatius.
Sir,
Well done. Well done, Iggy.
is there a specific reason you make the F like that?
Stop right now.
Cause it's pretty.
Because when I teach math, I do this,
Also,
F of X,
sir, isn't a capital
function. So I just get used to
Sir,
it.
isn't a capital F force there? Sir, he called me.
Yes, yes. Yeah. But I could have left it, straight. Okay, so our first problem is a skateboarder starts from rest and maintains a constant forward acceleration of 50/100 meters a second squared for 8 4/10 seconds. What is the rider's displacement after this time, right? And so what do? How do we solve a problem like this? Well,
X,
we
F.
created charts. What are we looking for? We're looking for final displacement, right? That's what we don't know. What have we been given? We've been given
VI,
acceleration
velocity,
and time.
and
Our
velocity initial.
acceleration, where is the velocity in that problem?
Starts from rest. Starts from rest.
Okay, so you can say that VI is 0
So
meters
smart, bro.
a second. Thank you. You're right. I'm wrong.
Yippee.
And T is 8 4/10
Yep.
seconds. Okay. Good?
Yep.
Now, if we're solving for displacement, we could use one of two. But we don't have a final velocity. So let's go with this bad boy here. Right?
Yeah.
One on the bottom.
Yeah.
It's already solved for final displacement. We don't have any initial displacement, so we'll ignore it.
So do we just leave that at XI or do we just not?
So we won't even put it into our formula. We don't have an initial displacement. Sometimes there'll be a problem that starts out 100 meters ahead. That's not this problem. But do we need to put in the second term? Do we need to put in VI times T?
No. Cause
What's 0 times 8.4?
yeah, dummy.
All right, let's chill.
Hey!
I love how Milky Milk is talking. Like
You very well could put it in there, but it's going to be 0. Right?
So do you just put in 0 instead?
So you can put in 0 meters a second times 8 4/10 seconds, right?
Right, an opportunity. My bad, sir.
What did you say?
And then we're going to add in our 1/2 times our acceleration times our time squared.
Uh, 17.64 meters.
Sounds about right.
Sir, Coke or Pepsi?
Who just said Pepsi?
Coke.
All right, thank you.
Exactly.
So 0 times 8.4 is 0. Does that cancels with that? Second squared cancels with second squared. This whole thing is 17 and 64 100. Good?
So is the answer 17.64?
What happened to the
So how did you get that?
1/2 times 1/2 is 1/4. 1/4 times 8.4 squared gives me 17.64. Now, if you wanted to, you could go ahead and do it the long way.
Let's just do
And
it.
8.4 squared is 70 and 56 100ths. And then multiply that by 1/2 and then another 1/2. Right? Divided by 2. Divided by 2. And you get to 17.64. Okay? You can do it the long way. I won't be offended in the least if you take your time with calculator, but you might as well do it all at once.
I divided it instead of
What?
multiplying, that's fine.
This calculator, this.
I have no idea why you insist on using that calculator.
I got it, I got it.
All right. Can I have that calculator?
You're
right. I'm not sure.
I was thinking the exact same thing.
It's not the right calculator. There's no reason you should have spent $200 on a calculator. And there's no reason to use that calculator on an SAT. That TI-84 or 85 is the calculator you're supposed
There's
to
a
use
TI
on the
85.
SAT. Yeah, 85 is the color version.
Oh, no.
There's
TI-84.
colors? There's colors
That's
now.
what I got.
Yeah.
That's what I have.
What do they need
Yeah.
colors for?
There's
numbers. What?
Mine's
You're
colored.
gonna force you to take SAT.
I want.
Okay,
Like all this.
okay, great. Yes.
So this is.
What do they need colors for? They're numbers and letters.
It's for the graphics.
Oh.
Are we okay?
Yeah.
So far, so good.
I'm a little bit unsure. I keep getting 2.1.
2.1. Why 2.1?
I don't want to break.
So, did you put into the calculator? Did you put into the calculator
Bro, have that too, bro.
0.5 times
See, look, I have other colors.
0.5
I have other
Times.
colors. Look at this.
8.4 squared?
I forgot that the square applies to the number, not just the unit. Shane, give me the calculator.
All right. Hey,
You make it black.
everyone in the room. These are your keystrokes to put into the calculator.
Right now?
That's how you get your 17.64.
Wait, sir, I'm dumb. But is it like the square cancel?
What?
What's that?
Units cancel?
Yeah, but you also cancel the square.
No. 0.5 times 0.5?
I'm talking about 8.4 square. Why?
Because you have to square the time.
Oh.
The only reason it canceled is I was canceling units to end up with meters. My fault.
How
My
did
fault.
you get 2.5?
That's how I confused Thornburg by doing it that way. What?
So the 2 halves came from the half on the outside of the whatever, and then the other one came from 0.5 MS.
Yep.
Okay.
That was my acceleration. Good? So far, so good. Any other questions? No? How's your finger? Is it still pretty, pretty gross? Looking better? Let me fix the chart.
People on a monkey.
I'm gonna change the chart a little bit because our next problem does not look for final distance. I don't think.
Yeah, sir.
Looks for acceleration.
It's also weird, sir, because it only gives you distance and time.
Distance and time. Oh no, oh no.
Not a lot.
Yeah, that's what I said, sir. Like that. Look.
All right, it only talks about distance and time, so we're still gonna use the last one, right? Sports car moves 100 meters forward in 4.5 seconds of constant acceleration. What is that acceleration, right?
Yeah.
So acceleration is what I don't know. We're not given any velocities, but we're given 100 meters
And time. 4.5.
and what we say 4.5 seconds?
Yeah.
4.5 seconds. Good? Great. We're still going to use the third one. But since we don't have any initial displacement or initial distance, we're going to use 1/2 AT squared. But we have to solve it for A. Okay? Solve it for A. First thing I have to do is get rid of that 1/2. How do we get rid of a half?
Multiply by 2.
Multiply by 2. Multiply by 2. All right, so I have 2x equals AT squared. How do I get A by itself? I divide by T squared. Divide by T squared. So A is equal to 2 times the distance divided by the time squared. Right? So I've rewritten this bad boy and solved for acceleration.
And sir,
Using algebra.
when does IQ start?
November.
Doing what?
That's
No,
not
you-
the answer though.
So we can put
It's
in
like a-
100 here and 4.5 here, do the math, and then come up with an answer. Right?
So would it technically be
9.18 meters a second squared.
And
9.9?
Yeah, basically.
2 times 100 meters. Sorry. What did you say, 4.5?
4.5
We're gonna say thank you for the laugh.
Hi, sir.
Sorry to interrupt.
Hi.
Was told to speak to Schuler.
Shoelace.
Shula!
Thought it was the Stalag 13 needs your attention. What?
Achtung!
Wait, isn't that Hogan's Heroes?
Sir, why'd you say danger?
That's it. That was it.
He is your new favorite.
There's a reason we get along,
Yes.
Barry. There's
Yes.
a reason we get along.
Yes.
It's one of our
Whoa.
all-time favorite shows. Yes, sir.
That's
So you know what Octo means, right?
That, so Hogan's Heroes is why I learned how to play the trumpet, because I loved the theme song so much.
Wait, what's the name of the main character? The actor, not the actor.
Who, Bob Crane?
Bob Crane. Thank you. He was the first porn star. Fun fact.
What the
Woo! He was a weirdo.
He was a weirdo.
He was a weirdo.
He was a very strange.
This
he
has
was the
just
very first
degenerated
guy
into
to
something-
build himself
How do you
out.
know this?
Sir, are we still on air? Oh, no.
We are.
Uh-oh.
8 meters per second, sir.
No one has to know that was.
Yo, Barry, you're gonna be put on the list, bro. I swear.
Huh? Oh.
You're not gonna.
Okay,
get
so
used
now
to
we have
that
meters over second square,
So it's
right?
20.
20.
20.
20.25.
20.
All right.
So 9.88 meters per second.
People were oppressed.
Which is just about
9.9.
9 and 9/10 meters a second.
You're so smart, bro.
Good? Now, is that annoying? Yeah, because you have to figure out which formula you're gonna use there to make it right. If you have to, please walk right through, wave as you go by. All right, now go away.
Good shot, stupid.
Door right next to you, you'll still walk right through the screen.
That's what I'm saying, sir.
Stupid.
Now, just
Flipping me, sir.
Just keep change flip.
unaware. Let's just call it unaware. Okay. Now, finally, we have an initial velocity. We good?
Yeah,
We
sir.
good? You with me?
Hurt.
You with me? It says the ball is rolling with an initial velocity of 1.6 meters a second.
Yeah, whatever.
The Aryan Association.
The next part says, If the ball has a constant acceleration of 33/100 meters a second squared, what is the object's speed? What is the object's speed after 3 6/10 seconds? So, which formula am I going to use? 1, 2, or 3?
1.
Two.
VITAT. So smart, bro. That's crazy.
VITAT.
Good job, Richie.
Thank you.
Okay, there's number 1. What we got, about 2.8?
Yeah.
It's basically a third, right?
Yeah, 2.8. That's what I got.
Basically a third? Basically,
Yeah. Yeah.
almost. So I just took a third of that and added them together. I didn't feel like walking over to I got lazy. Yeah. Yeah, you have to, man. You know, have fun. Have a great check. Mention my name, you'll get a good seat. Et cetera, et cetera.
But why not?
How far did it go in that time? How far did it go in that time?
I don't feel like it. I proved the standard. I think some breakers off the rest of my stuff for a long time. Yeah, it's just not easy to get them up. I like to.
All right, I think what I'm gonna do is turn this off, because there's no reason for me to be recording this if you're not gonna pay attention,
I'm paying attention.
okay? So I'm done with the video.